At the forefront of the electric vehicle industry, energy, efficiency, and sustainability have become paramount concerns. For years, Tesla has been leading the charge with the revolutionary electric motors, having been praised for their unparalleled performance, longevity, and low-maintenance design. But just when you thought they couldn't get any better, Tesla has once again pushed the limits of what's possible. Elon Musk has just unveiled Tesla's latest motor, which has already started causing havoc in the industry. It's time to witness how this groundbreaking drive unit promises to change the industry forever, undoubtedly revolutionizing the way we think about electric transportation. And before we continue, stop using Yahoo Finance, stop using Google Finance, and have a look at our website, themarketisopen.com, where we have instant stock quotes and a brand new set of financial data going back 15 years, and it's all freely available. Tesla has been designing its own drive units since the founding of the company, which was originally incorporated as Tesla Motors, spearheaded by Elon Musk, who has been the company's product architect since the beginning. Tesla's innovative approach to engineering and manufacturing has allowed it to remain at the forefront of the industry. The original Roadster, which was designed almost 2 decades ago, contained power electronics in a drive unit that was built and designed by Tesla, but licensed technology from AC Propulsion, which was the proof of concept at the time. With the release of Tesla's Model S in 2012, the drive unit was brought completely in-house and no longer licensed technology from third parties. Today, Tesla's induction and permanent magnet motors are 2 of the most advanced and efficient electric motors in the market. The induction motor was first developed by Nikola Tesla himself in the 1880s, and it remains one of the most widely used electric motors today. In an induction motor, a series of electromagnets are used to create a rotating magnetic field, which in turn induces an electric current in the motor. This creates force that drives the rotor, producing a rotating mechanical energy. The design of an induction motor is relatively simple, with fewer moving parts than other types of motors, which makes it highly reliable and low maintenance. On the other hand, permanent magnet motors use a series of magnets to create a magnetic field, which interacts with the electric current in the rotor to generate motion. Unlike induction motors, PM motors have a fixed magnetic field, which makes them highly efficient and produces less heat during operation. This makes them ideal for use in electric vehicles where efficiency and reliability are crucial. Tesla has built multiple generations of each type of motor over the years, but typically uses both motor designs in each of its vehicles. In rear-wheel drive setups, a permanent magnet motor is used, and in dual-motor versions of the cars, they add an induction motor to the front wheels, and they can shift the power between these 2 motors to optimize for efficiency and torque across various driving scenarios. Typically, the induction motor is better suited for high-torque applications, such as acceleration or climbing hills, whereas the PM motor is optimized for efficiency, especially cruising at highway speeds. Tesla has also developed a new type of motor for its Plaid vehicles, which includes the Model S and Model X Plaid, as well as the Tesla Semi. Each of these vehicles currently ships with 3 identical Plaid motors, which are carbon-wrapped permanent magnet motors, offering an insane power curve that continues to output high power even at high speeds, whereas other types of motors tend to drop off after hitting their peak horsepower. Now, Tesla's upcoming next-generation motor, revealed by Elon Musk, takes a slightly different direction by focusing more on extreme scale. Tesla has not only innovated on characteristics that are very visible to customers like power and acceleration, as well as low energy consumption or efficiency, but one of the most important innovations, which often doesn't get included as something innovative, is cost. It takes tremendous effort to build high-quality products, but at the same time keeping the costs low, which means more people will be able to ultimately access and utilize the technology. A good analogy can be seen with Tesla's battery cell strategy, where the 4680 cell is optimized for manufacturability rather than extremely high energy density. Elon Musk even mentions this at Tesla's recent investor day, where he says that electric airplanes would need over 450 watt-hours per kilogram of energy density, which exists today and you can buy them, but they're quite expensive, even though Elon expects the prices to eventually come down. But the reason they're expensive is because they likely use harder to source materials or more complex manufacturing processes, and because of that they can't scale. The 4680, on the other hand, is meant to relieve bottlenecks in materials and manufacturing to truly be designed for scaling and reducing cost. Now, Tesla has already been pulling costs out of their Model 3 motor, which despite the name is actually being used in all of their vehicles. Between 2017 and 2022, they reduced rare earth metals by 25%, took out 20% of the weight, and cut down the factory size for building these motors by an astounding 75%, which helped cut costs by 65%. The cost of the factory itself ultimately end up within the cost of the product, since Tesla needs to charge enough to cover all of their expenses. So improving the factory is another critical piece for reducing the cost of the motor itself. Now, car specialist Sandy Munro and team noticed at the Investor Day event that Tesla is using a hairpin electric motor design. Hairpin motors are a type of electric motor that use hairpin-shaped stator windings instead of traditional round wire windings. One of the main benefits of hairpin electric motors is their increased efficiency, which is due to reduced winding resistance and improved heat dissipation. The hairpin windings also allow for a greater copper fill factor, meaning more copper can be packed into the same space, resulting in a more powerful magnet and therefore motor. Now, hairpin motors are relatively new technology that have been gaining traction in the automotive industry. Companies like Volkswagen, BMW, and General Motors are already using hairpin designs in their electric vehicles, and it looks like Tesla has begun using them as well. And they showed at Investor Day their automated machinery, which is already in action for assembling these motors. One of the major challenges for implementing hairpin technology is the accuracy of the process of bending and welding the copper hairpins, as incorrectly welded hairpin ends can cause electrical losses. Now, what's interesting about Tesla is that they've written custom software to model and simulate the entire motor along with its rotating electric field. Tesla boasts that its software is faster and more accurate than other competitors' software, allowing them to quickly iterate through millions of designs to choose the best one. This is actually well suited for hairpin technology, which is still being heavily researched, and it may overlap with Tesla's artificial intelligence expertise. For instance, AI can be used to optimize the hairpin winding pattern to reduce the motor's resistance and improve its overall efficiency. And so once again, Tesla's software capabilities are really what's central to keeping them ahead of competitors. Furthermore, Tesla builds their high-level chips in-house, and according to Sandy Munro, who's torn down multiple Teslas in competing vehicles, Tesla's chips are unmatched in the industry, but they continue to take them to the next level. In Tesla's chip used for charging, where they say that every electron that moves you down the road passes through one of these chip packages, they've been able to cut down the amount of heat by 2 times and reduce the number of microprocessors from 4 to 1, which have to orchestrate a complex and compute-intensive switching of transistors, meaning that they can make the chip smaller and reduce the amount of silicon carbide, an expensive material, from being used, and the chip still has the same, if not better, capabilities. Colin Campbell, who presented this at Tesla's Investor Day, drove the point home, stating, "We can do what no other company can do." And that's because Tesla is highly vertically integrated, planning to produce 100% of all of their high-level vehicle components in-house for the next generation platform. And they have an organizational structure that allows every stakeholder team to communicate and participate in the design and manufacturing process. Again, each piece boils down in major part to software. Even the hardware is designed in software, which is Tesla's specialty, having roots in Silicon Valley. Now, one of the biggest reveals from Elon Musk is the amount of rare earth metals that the next generation motor will use. No rare earth metals at all, which is something that no one thought was possible. Tesla claims that by doing this, they aren't sacrificing performance at all. If anything, these new motors will have lower costs and astoundingly higher efficiency with zero rare earths. This on its own is shocking and has already caused some shakiness in the stocks of some rare earth miners, including MP Materials, which was down 13% after Tesla's announcement, although recovered part of that back a few days later. But the real benefit for Tesla is that the next generation motor will be able to scale much faster with no bottlenecks in sourcing rare materials that may have environmental and social impacts. Tesla also stands to save hundreds of millions, if not billions of dollars, long term by completely removing these expensive materials. According to Tesla's presentation, they previously used 500 grams of one unnamed rare material and 10 grams of two others in each drive unit. While Tesla didn't specify which metals these were, the three main rare metals typically found in Tesla's permanent magnet motor are neodymium, praseodymium, and dysprosium. These metals are used to make the neodymium iron boron magnets and are said to be an essential component of the motor. Yet Tesla has found a way to do without them. Some of these metals cost over $100 per kilogram, or over $100,000 per ton. The current price of neodymium is about $123,000 per ton. If we assume that this is the material with the 500 grams in each motor, and Tesla produces 2 million permanent magnet motors this year, that's $123 million being spent on this one difficult to source rare earth metal that Tesla just removed from its next generation drive unit. And these savings would have an even higher impact as Tesla plans to scale over the coming years to its goal of 20 million vehicles. Now, Tesla's motor will also be using 75% less silicon carbide, as discussed earlier with the reduction in chip size. But this may affect multiple types of chips that the motor uses. For instance, Tesla reuses the inverter and casing for all of their vehicles, meaning that you can take the inverter out of the Model Y and it fits perfectly into the Model S, even if the inverters themselves are slightly different. So this is great for compatibility, but it has limitations in that Tesla can't make a drastic change without breaking this backward compatibility. However, with the next generation powertrain, Tesla needs to dramatically cut costs to get the price down, and so it's the perfect opportunity to redesign all of their components, which will power Tesla's upcoming set of vehicles for the next half-decade. All in, one of the most incredible stats revealed is that the entire next-gen drivetrain will cost just $1,000 according to Tesla. Sandy Munro and team commented that competitors may be roughly triple this number. And Sam Corris from ARK Invest did some back-of-the-napkin math showing that at $70 per kilowatt hour, a battery pack for this next-generation vehicle could cost about $5,200, plus $1,000 for this new powertrain, bringing the total to $6,200. Now, he used a rule of thumb, which could break down if Tesla has made so many drastic changes to the vehicle design, but he estimates the drivetrain is about 25% the cost of the vehicle, and therefore Sam Corris estimates a $25,000 car, which seems to line up with Tesla's plans. However, the battery size that Sam Corris used in his calculations seems too large, since the standard range Model 3s today use a 54 kilowatt-hour battery pack, and this next generation vehicle is set to be even smaller and lighter. So this reply from RE Hedgehog actually seems more accurate, with a 45 kilowatt-hour pack resulting in a $4,100 powertrain and a $16,000 car using Sam Corris's template. This actually lines up better with where Tesla would want to be, since the vehicle cost must be much lower in order to achieve a $25,000 sale price and still make a profit. And this isn't out of the question, as there are a number of gas cars that sell below this price, and technically, electric vehicles which have fewer parts should ultimately become cheaper than their ICE counterparts. What really struck me is Tesla saying that no one else can do this except for them, and we're seeing that the vertical integration and extremely flat organizational structure, which allows Tesla to build everything themselves while everyone else is busy outsourcing parts and software, is now going to be on display even more as Tesla widens the gap against competitors who are still playing catch-up to Tesla's older generation products. So do you think over time, Tesla's next generation motor will ultimately replace the current design in most of its vehicles, given its cost effectiveness and higher performance? Don't forget to watch my video on Tesla's trillion-dollar robot opportunity. Please hit the like button and subscribe. We would really appreciate that. And a huge shout out to all of our patrons that help to support our channel. Your support helps us to continue to make great content. Thank you guys so much for watching.